Welcome back, Patriots. I am Mr. Love, aka the Math Patriot, bringing you another lesson in the fun and exciting world of high school geometry. Now, we're doing another lesson today where I'm not in front of a live class, and the good news is I believe I've got all of my pen issue fixed from last time, so hopefully that won't be an issue. I was using PowerPoint, and it doesn't work well with the Microsoft Surface Pen. But last time we covered the the segment relationships within, or how to do proofs using our segment postulates. Now, typically the only one we really had to do there was, definition of congruent segments, when we also had the angle addition postulate that came in important. Now, today we're going to be doing angle relationships, and angles have quite a bit more stuff that we're doing. So there's a few more postulates, a few more theorems, that sort of thing. Now, as we go through here, it's going to be very important for you to actually take a look at and spend some time looking through and, yes, memorizing all the different theorems. You need to make sure you understand what the conditions are for each proof, as well as what the conclusion is. And the reason that the conditions are important is because if I see that there are 1, 2, 3 conditions for a theorem to be true, and all 3 of those are there, that means I can naturally jump to the conclusion. So we've got to make sure that we understand all those, because there's a couple, like you'll see in a second, the supplements theorem, the congruent supplements theorem, that can make a proof go from like 6 or 7 lines to just a single, like 1 or 2 lines. Okay, I said single, but it's probably 2 or 3, somewhere in there, really, really short, if you recognize when all of those conditions occur. So, first thing I want to point out is that our reflexive, symmetric, and transitive properties apply to angles as well as to segments. Now, last time when we had segments, remember that there was a difference between segment AB and the distance between A to B. We do the exact same concept here in our angles, but this time we have our M's out in front. Remember, the N stands for measure. So anytime you see that M out in front, you're talking about the measure of the angle. And if there is no M in front, you're talking about the angle itself. So whereas this thing, angle 1, is literally angle 1, this is the measure of angle 1, would be something like 60 degrees. So we're going to have to be converting back and forth. The way we convert from an angle to or congruent angles to equal measures is by the definition of congruent angles, and you'll see that as we go through. All right, let's do our first example here. If angle A is congruent to angle B, so let's just go ahead and draw our pictures here. I've got angle A and angle B, and those two are congruent. And measure of angle B is 2 times the measure of angle C. So here's what I'm getting. I've got angle C here, and this distance, if I take 2 of those, so I'm going to go ahead and draw another one. If I get 2 of those, that exactly equals my third one. Or sorry, my original, A and B. It also tells me that measure of angle C is 45 degrees. Now I'm wanting to prove that the measure of angle A is equal to 90 degrees. Now, just a brief little roadmap here. I mean, I drew that wrong. Actually, I should make that green. The green is 45 degrees. Well, if this is 45, then this is also 45, meaning the whole thing there is 90 degrees. So that means this over here is 90 degrees, and since angle B is 90 and A is congruent, then that one's going to be 90 as well. Okay, so I can logic through that. Now the problem is, how in the world do I go ahead and prove it? Well, first off, I want to go ahead and write out all of my given information. Angle A is congruent to angle B. Angle B is equal to 2 times the measure of angle B is 2 times the measure of angle C, and the measure of angle C is equal to 45 degrees. All of that is given. All right, so next, let's see what we can do. It looks to me like I've got the measure of angle C equals right here, and I'm going to substitute it into that. So I'm going to go ahead and recopy this down. Measure of angle B is equal to 2. Now, instead of measure of angle C, I'm going to write in 45 degrees. Now, I'm going to go ahead and simplify that down. and that is 2 times 45 is 90. My reasoning there, that is just a simple substitution step. Now, for the next step, since the measure of angle B equals 90 degrees, and the measure of angle A is congruent to the measure, angle A is congruent to angle B, I need to now convert to angle measures. So I know that because angle A and angle B are congruent, the measure of angle A is equal to the measure of angle B, and that is by the definition of congruent angles. All right. Now that I know that measure of angle A is equal to measure of angle B, I'm going to take the opportunity to substitute this into the measure of angle B. So the measure of angle A is equal to 90 degrees, and that is substitution. Technically, you could have probably also used a transitive property there, but now I have done measure of angle A equals 90 degrees. I'm going to go ahead and throw in my QED because I'm finished. Now, if you need time to go back through and look at that, please, you always got that pause button. Hit pause, come back when you're ready. All right, a couple things we got to get out of the way. We got the protractor postulate, very similar to the ruler postulate, except this one is for angles as opposed to segment lengths. So basically, the idea is that any angle I could place a protractor on top of it such that the vertex is right at the center of the protractor, and then any angle could be measured on the protractor, and every single angle would match up to a point on the protractor. Now, it might be in between, like this one you can see is actually at like 146.3, something like that. So it's possible to have decimals. They don't have to be whole numbers, but every single angle can be measured, and it will be between 0 and 180. We're taking the shortest distance from A to B. We're not going to try and do this whole wraparound thing. So, again, very rarely will we ever actually call the protractor postulate. The thing we're actually doing, though, is we're using the protractor postulate to get the angle addition postulate. Now, remember that the segment addition postulate said that if you have, and I'll use different letters here, X, Y, and Z, that the distance from X to Y, this first distance on the left, plus the distance from Y to Z, the right-hand distance, add those together, and I get the full distance from X to Z. The angle addition postulate is the exact same thing. If I add the first angle plus the second angle, I get the greater angle. That's all that it's saying. Very similar to the angle, to the segment addition postulate. Now, a couple more that we need to worry about here. First off is the supplement theorem. Now, this is where we're talking about being very important for us to realize what the hypothesis or the conditions were, and then what the conclusion is. So reading through here, I see that if two angles form a linear pair. Now, I'm looking at these two linear pair are adjacent angles that whose rays make opposite rays or a straight line. If I have a linear pair, then they are supplementary, which means I see this, the conclusion I make is that angle 1 plus angle 2 is 180. I could also write it as angle 1 and angle 2 are supplementary. Okay. Now, exact same idea, but with a for the complement theorem, except it's with 90 degrees instead of 180. If the two non-common sides of adjacent angles form a right angle, which means I've got two adjacent angles, they share a vertex and a common side. If the two non-adjacent sides, which are this one and that one, the one going up and the one going to the right, if they form a right angle, then the two are complementary. So if I see this, I can say those two are complementary and use the complement theorem as the justification for it or the reason. Let's keep those in mind as we go forward to our proofs here in a second. Also, we already covered these on a previous slide, so I'm not going to do it now. Now, the congruent supplements and congruent complements theorems are actually pretty powerful in what they can do. So the basic idea is, and forgive me here, I'm going to get rid of this for just a second. We'll talk about the base case, and then we'll come back to the extension in a second. So first off, angles supplementary to the same angle. Oh, we got to get rid of that one too. Angles supplementary to the same angle are congruent. So here's what we got. Angle 1 plus angle 2 is equal to 180 degrees. That's what's stated here. We also know that angle 2 and angle 3 add up to 180 degrees. That is what's stated here. Well, it makes sense that if 1 plus 2 is 180 and angle 2 plus angle 3 is 180, that since angle 2 is the same measure on both of those addition statements, since we got angle 2 here and angle 2 here, then angle 1 would have to equal angle 3. I mean, I realize that throwing out examples is not actually a proof here, but let's just say that this one was 100 degrees. Well, not 1,000, 100 degrees. Well, in order for that to happen, angle 2 would have to be 80 degrees, and then because of that, these two had to be 180. Subtract that out, I got 100 degrees. These two end up being equal to each other. Okay, so the congruent supplements theorem is very powerful, especially because of this piece that I erased a second ago. The or two congruent angles. All right, let me throw out another scenario here. We've got angle 1 and angle 2. Angle 1 and angle 2. We've also got angle 3 and angle 4. Now let's say that I also tell you that angle 1 is congruent to angle 3. Well, angle 1, the measure of angle 1 plus the measure of angle 2 equals 180. The measure of angle 3 plus the measure of angle 4 is equal to 180. But since the measure of angle 1 is equal to the measure of angle 3, let me make that an equal, not a congruent sign, then I'm allowed to make a substitution and say that the measure of angle 1 goes in there. So measure of angle 1 plus the measure of angle 4 equals 180 degrees. And now, since the measure of angle 1 is in both of these, we can conclude that angle 2 and angle 4 must be congruent. Now, the power of this is that as long as I have two congruent angles, and I say 2 is supplementary to 1 and 4 is supplementary to 3, then therefore I can jump all the way to angle 2 is congruent to angle 4. Now, I know that's an overly detailed explanation of it. We'll actually see that one get used in a proof here in a minute. Now, we've also got the congruent complements theorem. Exact same concept, except we're talking about 90 degrees instead of 180. So they read the exact same. We're going to use those. I'm going to use those honestly as often as possible. There's a couple times where I didn't use those, and a proof ended up being about 7 or 8 lines long. And then when I did use it, the proof ended up being just 3 lines long. So, in figure 1, angle 1 and 4 form a linear pair. I'm going to go ahead and mark that linear pair with yellow. So those two are a linear pair. Measure of angle 1 plus the measure of angle 3, so 1 plus 3 is equal to 180 degrees. We're wanting to show that angle 3 and angle 4 are congruent, and pink is the thing that I'm trying to show. All right, well, let's just see where we got here. Let's go ahead and copy in our givens. So we got angle 1 and angle 4 form a linear pair. And my reason there is given. I also know that measure of angle 3 plus the measure of angle 1 equals 180 degrees. That's also a given. All right, so let's look at what we have here. Angle 1 and angle 3, angle 1 and angle 4 form a linear pair. Well, if I look back at the supplements theorem, the supplements theorem says that if two angles form a linear pair, then they are supplementary. So I know that angle 1 and angle 4 are supplementary because they are a linear pair. Now, I also know that angle 1 and angle 3 are supplementary. And the reason that I know that is because they add together to give 180 degrees. That is the definition of supplementary angles. Okay. Now, I'm seeing that angle 1 is in both of these. Angle 4 is supplementary to angle 1. Angle 3 is congruent to angle 1, which is the condition angles supplementary to the same angle are congruent. So that means that angle 4 and angle 3, angle 4 must be congruent to angle 3. And that is by the congruent supplements theorem. Well, now I've got angle 3 is congruent to angle 4. I've proven it, so I'm going to put my QED on there, and I'm done. Now, again, I could have done this without the congruent supplements theorem. However, that would have taken a little bit of substitution and a little bit of an algebraic proof. That's the simplest way of getting there. All right, let's look at number 3. Okay, angle NYR and RYA form a linear pair. We also know that AXY and AXZ form a linear pair. I also know that RYA, so RYA and AXZ are congruent. Prove that NYR and AXY are congruent. So NYR and AXY. I made a mistake there. Forgive me. So it said here RYA and AXZ. Sorry, those two are congruent. I'm trying to prove that these two in pink are congruent. Okay. Let's get in our given information. Angle NYR and angle RYA are a linear pair. I'm going to abbreviate that for a second. We also know that angle AXY and angle AXZ are a linear pair. And I also know that angle RYA is congruent to angle AXZ. That is all of my given info. All right, let's review what we have here. It says these two are a linear pair. Well, I know that my supplements theorem, I guess I'll do it in blue, it's no big deal. Supplements theorem says that when I have a linear pair, then those two are supplementary. So I know that angle NYR and angle RYA are supplementary. I also know by the exact same logic that AXY and AXZ, these two are supplementary because they're a linear pair. Also using the supplements theorem, angle AXY and angle AXZ are supplementary. All right, now I know that angle RYA and AXY are congruent. These two are congruent. So I've got, well, let me do that with yellow instead of blue. I'll make it easier to see. What is wrong with my pen? There's a yellow. Okay. Angle, and then boom. There we go. All right, so RYA and AXZ, those two are congruent. So RYA is here, and AXZ is here. So now I have two angles that are both supplementary to congruent angles. Now when I go back and look, that is what this section of the congruent supplements theorem says. Angles are supplementary to congruent angles are congruent. So since NYR and AXY are supplementary to congruent angles, then I know, let me do this in pink here, that angle NYR is congruent to angle AXY. And that's by the congruent supplements theorem. So I've proven that NYR and AXY are congruent. There is a QED. All right. Talk about our vertical angles theorem. If two angles are vertical angles, then they are congruent. Now remember, vertical angles are angles that have a vertex but do not share an adjacent or a common side. So these two are vertical angles, and it says they're going to be congruent. And then also the angle 2 and angle 4 are congruent. So anytime I see vertical angles, I can just throw in that they are congruent to one another. Let's see how we can use that. I'm going to go ahead and write in my given here. Ray DB bisects angle ADC, and that is given. All right. Now, whenever I see that a ray bisects an angle, I got to remember what bisect means. Okay, when it bisects, it means that it cuts it exactly in half. So ADC is here. So this angle is equal to that angle. Well, let's go ahead and write that into my proof. Angle 1 is congruent to angle 2. And the reason that I know that is the definition of an angle bisector. Okay, now I'm looking at it, and I see I need to show that angle 2 is congruent to angle 3. I need to show that these guys are equal to each other. Well, I don't have a direct route there. Oh, but I could say I see vertical angles here. I see that angle 1 and angle 3 are vertical angles. So I'm going to go ahead and write that in there. Angle 1 and angle 3 are vertical angles. Now I know that by the definition of vertical angles. And now, because they're vertical angles, I can say that angle 1 is congruent to angle 3, and that is based on the vertical angles theorem. That anytime I have vertical angles, they are congruent. Now I know that angle 1 is equal to, or congruent to angle 3. I also know that angle 1 is congruent to angle 2. Therefore, angle 2 must be congruent to angle 3, and that is by the transitive property. You could also put substitution there. All right, I proved what I was set out to prove, so I've got my QED on there. All right, one last one, and then this lesson is yours. Oh, I forgot. We got to talk about our right angle theorems. Okay, these perpendicular lines intersect to form 4 right angles. So if 2 lines are perpendicular, then they form 4 right angles. So I know that these guys are right angles. Also, I know all right angles are congruent. So if 2 angles are right angles, then they are congruent. That's easy. They're all 90 degrees. Okay, 211. Perpendicular lines form congruent adjacent angles, which is the same idea. If 2 lines are perpendicular, then the adjacent angles, or the linear pairs 1 and 2, are congruent. They are adjacent, also congruent. Okay, if 2 angles are congruent and supplementary, then each angle is a right angle. So if angle 5 and angle 6 are supplementary and they're congruent, so they add 180 and they're equal, well, they have to be right angles because the only way to make that mathematics work out is for each of them to be 90 degrees. Also, if 2 congruent angles form a linear pair, then they are right angles. Notice that it says if 2 congruent angles form a linear pair. Very similar to 2.12 up here, because linear pairs are supplementary and they're congruent, once again means we have right angles. All right, let's do our last example, and then the lesson is yours. Once again, I'm going to go ahead and get my given information in there. Angle ABB, ABE, and angle DBC are right angles, and that is given. Okay, and those are marked as right angles in the pictures. I don't have to worry about doing that. I'm wanting to show that ABD, which is here, is congruent to EBC, which is there. Well, it looks like, because I'm dealing with, I know that ABE is a right angle, it looks like I'm going to have to be using the angle addition postulate to add these 2 angles together to get the greater angle. I'm also going to do the exact same thing here with this angle. So I'm just going to go ahead and invoke my angle addition postulate and say that angle ABD, well, measure of angle ABD plus the measure of angle DBE is equal to the measure of angle ABE. So ABD plus DBE equals ABE. That's one I highlighted in yellow. I'm also going to now do the one I highlighted in blue. The measure of angle DBE plus the measure of angle EBC is equal to the measure of angle DBC. That is based on my angle addition postulate. All right. So it looks like since those two are equal to each other, well, since these two add together, what that means is that ABD and DBE are complementary. So angle ABD and angle DBE are complementary, and also that angle DBE and angle EBC are complementary. All right. Actually, you know what? I didn't even really have to use this angle addition postulate because I had this one up here. I just realized that I dropped it. So I'll give it a second for that to refresh. The complement theorem. The two non-common sides of two adjacent angles form a right angle. Okay, I didn't have to do all that. So while this line is true, this line is technically not necessary at all. I could go straight there because of the complements theorem. Okay? And now I'm seeing that DBE is in both of those. And since I've got two angles that are complementary to the same angle, then the congruent complements theorem says that if two angles are complementary to the same angle, then those two must be congruent. So angle ABD is congruent to angle EBC. All right, I've proven what I sought to prove, and so that is QED. I am done. All right, now, I guess I could have gone back and edited out the fact that I did this to begin with, but I think it's honestly a good lesson for you to learn that there are multiple routes you could go on these things. I could have finished it out using this direction, and just because you can invoke a postulate doesn't mean that you should invoke it. In this case, it was extra work that I didn't need. There's almost always a more efficient route. Yes, you can eventually find the most efficient, but I mean, I could have gone that route and add these things up to 90 and subtracted and substituted, but that would have just been too much work. So, hey, this ended up being a three-liner, okay, using the complements and the congruent complements theorem. Well, I hope that helps. Feel free to give me any questions either in class or in the comments. And as always, guys, please stay patriotic.